question before. So we don't need to write new stuff down because I think you've already written stuff, right?
Yep.
So we're back to our patterns. We've had a couple of lessons of break because you did your assessment. Charlie? We did our assessment and then we did reviewing the assessment. We're coming back to this now. So we're talking patterns. We talked about the core of the pattern.
Should I just write it now because I wasn't there for the beginning?
Well, we'll do it now and we'll start with the next example and you can write that. Okay? Right. Yeah? You probably weren't here at that time as well. So that's why I'm going to go through it now. So draw the next two shapes in the pattern. So what we did was explain how the pattern works. Could you remind me how this pattern is carried on? Okay.
Add 3.
We just add 3 every time. So the core of the pattern, look, we've got 3, then we add another 3, then we add another 3. So to explain the pattern in words, we have leaves that go up by 3 every time. Okay? We then wrote this pattern as a sequence of numbers. So that was 3, then 6, then 9, then 12, then 15. It says 5. Do you remember what these numbers were called?
Linear pattern?
It is a linear pattern, but each number is a what? Matt? Begins with T. Term. Good. This is the first term, right?
Oh yeah, and that's the
Second term. Do you remember? I gave you something else, then we'll write it a sec. Is the pattern linear?
Yes.
Why?
It's consistent, adds the same amount.
It has what we call a common difference. We add the same on. Each time we add 3. Now, I went a little bit further before, which is when we said n is 1, 2, 3, 4, 5. That means the first number, the second number, the third, the fourth, the fifth, and so on. And the number is, well, we had L for number of leaves, yeah? Which is 3, 6, 9, 12, 15. And we said, right, if one of the shapes has L leaves in it, how many leaves will there be in the next shape? And we said it was
2. L equals
L plus 3. Not yet. Remember I said that the next term was just L plus 3. But then I said there was a general rule. And the general rule was, if I want to know the number of leaves, I take the position in the sequence and I multiply that by 3. Okay? Because the fourth number is 4 lots of 3. The fifth number is 5 lots of 3. So 3, why did I put 3n instead of n3? Or, no, Chrissy? Well done. You have to put what you know first. And 3 is a known thing. N is a variable at the moment. Alright? Now it then says, determine what the 10th term in the sequence. Well, that's now super easy. Because the 10th term will just be 30. 3 times 10.
You can get like the 1,000th.
And we can get the 1000th term, the 102nd term, whatever we want. Yeah? Now, it says, will the number 30 be in this sequence?
Yes.
Yes.
Yeah, we just worked it out. That's a rubbish question, isn't it?
And
Alright? Can you tell me a number of leaves that will not appear in the pattern? You ask for lots of them. Charlie?
11.
11.
23.
23. 7. 2. 29.
68.
68. 5.
7. Oh wait, sorry.
Why not Why 18? Why will 18 appear?
Because it's a multiple.
So good. I wasn't even expecting that word, but you said it straight away. Basically, our numbers are always going to be the multiples of 3. 3, 6, 9, so on, like you've just been doing, right? Multiples of 3. Because how do you get the multiples of 3? You take a number and you multiply it by 3. So any number that is not a multiple of 3. So will the number 30 be in the sequence? We can say yes, because I just found out in F that it was. But we could also say because it is a multiple of 3. Yeah.
The 10th term will be 30.
I believe I've just been saying that for about 5 minutes.
Oh yeah.
Yeah, but yeah, you're right. Charlie.
So like in coding, n is the variable.
Exactly, n is the variable.
Equals plus 1,
Yeah.
plus 3.
Right, let's go through another question then. All right. So again, this is a pattern. All right. The core of the pattern is
Plus 4.
the thing that stays the same each time.
It's a triangular sequence.
It's a triangular sequence.
Not a sequence.
Plus
It's
4.
nothing to do with triangles.
Quadratic.
No, no, it's not quadratic. It's actually all going to be linear. Well, right, I'm going to get you to do this question. So it's the same setup. How do you find the next number? Is it linear? Determine the 30th term. Right? I know it doesn't ask you for the equation, but see if you can find it. Alright? So, I don't want you to stand up now and tell me of it. I want you to do it in your books or from the charts. If you would now want to know what page this is, alright? We are on page 92 in the textbook. Alright? I will leave this on the screen for anyone that doesn't have a book to view. Alright? Have a go at carrying on. If you do not need to draw the pattern, guys, you do not need to draw the pattern. Although if you're already doodling all over your page, I don't see why you shouldn't want to draw the pattern.
I want to.
So, nice and simple to begin with. Explain pattern in words. Add 4 each time, yeah? It goes up by 4. So it's 1, then add 4 is 5, add 4 is 9, add 4 is 13, add 4 is 17, and so on. Okay. Now, if I'm just going to add this, so n is 1, 2, 3, 4, 5. I'm going to give you a tip in a minute for how to find the equation. Some people might already have it. Some people, or the general rule, sorry. Some people might have it, some people won't. But I'm going to give you a nice, simple tip that you'll want to write down. Okay? First of all, though, is this a linear pattern?
Yes.
Why?
Because it always is. Keeps saying the same thing over and over.
Exactly. It's add 4, add 4, add. Now, if it was a pattern that was times 4, times 4, times... Is that a linear pattern?
Yes.
It doesn't always have a number. It changes.
Okay, it's the difference to the two numbers that matters.
Yeah, because
Multiplication, if you multiply the same, it is still a sequence, but it's called an exponential sequence. Because if I times by 4, then times by 4 again, it's 4 to the power of 2, 4 to the power of 3, 4 to the power, and it becomes 4 to the power of n, which is an exponential one. It is only linear if we add or subtract. Charlie?
So, but what if it was divided by 4? Would that still be linear pattern?
No, that would also be exponential.
It'll just be like
So the Fibonacci sequence would be a linear.
No, Fibonacci is definitely not a linear. This is why, if you look at nature, very little stuff is straight lines. There's spirals and things, and that's where we get Fibonacci. We'll look at that in this unit. All right, so we know that it is linear because it's always add 4. Yeah. Say it again. Is linear? Doesn't linear mean? Is linear a type of leap? Is it? linear a type of linear?
Yes, it is.
You did?
Linear is linear.
Right, I did say I've got till 8 o'clock. If you want to chat, I'll probably phone Sargasso for my dinner, and I'm not sharing.
Oh.
And I'll have a pizza and donuts, and you can sit there and get on with it.
Can you get some lunch?
Right. Determine what the 30th term in the sequence would be without this drawing. The 30th is going to be a lot, right? Any ideas?
30 lots of wood.
30 lots of 4. That makes sense. It's not correct. Quite. Why not? Kenzie? Pardon? Well, 30 lots of 4 would be 120.
No, you can't bring your hand up. You can't bring it.
Aaron? 30 times 4 add 1. Almost, but not quite.
Oh, the way
Abby,
that
can you come down?
Guys, I'm not going to let Aviet because I know Yuma told Aviet. So I'm going to let Yuma explain.
Put your mask on.
So like the first one is only one water. So there's 29 4 and add 1.
So Aaron's view of it's a lot of 4 plus 1 works. 5 is 1 lot of 4 plus 1. Now if you look at it, look, here's the pattern. Here's a lot of 4 plus 1. I don't want you to. This one, look, if I highlight, it's 1, 2, 3, 4, like those. Okay? But on this third one, it's another set of 4. So this one has 2 lots of 4 plus 1 in the middle, the core.
Oh, I know.
So, like Yuma just said, when we get to the 30th one, we'll have only had how many lots of 4?
30 take away
29. Alright? The second one is 1. Now, the first one is no lots of 4. So, what we can do, hang on, I'm going to explain. So, the 30th term would be 29 lots of 4 plus the 1 in the middle.
117.
170.
I just did because 1 out of 4, so there's 3 remaining. You
Right.
have 3 remaining.
Guys,
You said all.
if one of the shapes has W drop limits, how many droplets will there be in the next shape? W plus 4. But I'm going to ask you for the general rule. So the general rule would be the number of droplets equals, what do we think?
1 plus 4 times n minus 1.
Okay, we could probably be simpler. Aaron?
Oh yeah. It's 4n minus 3.
Oh, I like that one.
Because I just add minus 3 because it's 1 and 1.
Now, let me just explain. I think Aaron and Abby were doing the same thing. They're saying the number of droplets is, when you take n, you minus 1 from it, and it's that many lots of 4. Then, plus 1. Alright?
Same thing.
But those two are the same thing,
You
which
just
we'll
open
talk
the
about.
bracket.
Next.
4 minus 1 equals 3.
People don't pack up. I've got till 8 o'clock. Right? Not joking. You've been talking. I get to talk more now.
You only got 4 hours and 15 minutes.
Yeah. Alright. So, can we just, the last thing we're going to do, so it depends how long this takes. I'll wait for you to do, like, pick up some stuff. Can we just check? I'm going to show you that this one and this one are the same thing. Does everyone understand where this one comes from?
Yeah.
Yeah? Everyone? Not sure everyone?
Yeah.
Because remember, guys, the n is this number. So if 2, we actually only need
Because they're
1 lot of 4. So we take the 2, subtract 1 from it, and it's that many lots of 4.
because they're
Which is
virtually
1 lot of 4, plus 1 makes the 5. The plus 1 is the one in the middle, yeah? Number 1 is 0 lots of 4, plus the 1. Number 4 would be 3 lots of 4, plus the 1. Now, Let me just ask you this, because like some people get excited by the algebra. 4 lots of n minus 1 means we have 4 lots of n and we have 4 lots of minus 1 and then we have plus 1. Now let me ask you, 4 lots of n is just written as 4n. Is anyone already, I'm doing this with my n2, so this would be good if you know. What's 4 lots of minus 1?
It's gonna take a while to get.
Well done.
Yeah,
Minus
it's
4 plus 1. 4n minus 3, yeah. Look, it's the same thing. We'll talk about it a bit more tomorrow. But how do we get this? But we're actually quite far ahead of where we need to be.